What's up, everyone? This is a kind of a little video diary blog as I'm kind of sharing my journey, trying to find a job. You know, like so many of us out there, either trying to find a job or trying to find better jobs. You know what I'm saying? Nothing against some of the jobs we have, but yeah, to try to find the right opportunity that's more like an alignment with who you are, what you bring to the table, as they say. And I'm sharing that journey for me. So I'm using Career Aider, which is an application I built to kind of like document the experience. So basically, I wanted to, this all started because, yeah, I'm trying to find the right opportunities. Um, there's a lot of opportunities in this world, but not all of them are the right opportunities or the best opportunities. So I built Creator in an effort to try to find to try to help me improve my chances of finding the right opportunity. You know, if you think about how big the world is, there are millions of opportunities out there that would be amazing for you and you for them. But the chances of you finding each other is like finding a needle in a haystack, which is why our job market is so fundamentally broken. Um, Contrary to some people's thoughts about the matter, this is a big part to play in it. So basically, I started CareerAider as a way to kind of document that process for me. So I wanted to find a way that I could keep track of all the jobs that I've been applying to so I can like easily find information about them. So I could like click on something and uh this is actually a great one to go to because this one I got rejected. Well, not really. Actually, it's in process. Yeah. So actually funny story about this, which should be this is a great time to talk about it anyways. Let me see if I can pull it up real quick. Um, see if I can get this notebook up. Yeah. So I actually started working on this curriculum for this technical interview. So to do that, I created a special Python cognitive apprenticeship notebook. It's the concept is supposed to take somebody who's a beginner in Python and turn them into a senior engineer. So it consists of 40 lessons. And each lesson has a video and has an infographic that kind of like talks about the lesson. And then it has uh, a quiz, flashcards. Each one also has an audio video explainer. So like this right now is lesson 20.
You ever wonder how your favorite app juggles like thousands of user profiles, each with its own unique details? Well, it's not magic. It's actually a really specific, super powerful way of shaping data. And that is exactly what we are going to break down today.
Yeah, then it has an audio um discussion. So like this is gonna be um each lesson has like pretty sure this is gonna be the let's see here.
This is the brief on nested data models. Okay, so we're moving past simple.
Yeah, so this is like lesson nine lecture. lesson 9. That's lesson rename. This is lesson 20. So this is lesson 20 lecture. This is the lesson 20. So this is what this sounds like.
This is the brief on nested data models. Okay, so we're moving past simple data types and getting into what data looks like in the real world. And that means lists of dictionaries. Seriously, this nested structure is the dominant mental model for data. You're going to see it in almost every professional API, database, and JSON feed you ever work with. First, let's talk about the collection of records concept. Think of it like this. A list represents many things, and a dictionary represents one thing with named fields. When you combine them, what you get looks a lot like a database table. The list is the whole table, and each dictionary inside, well, that's a single row or record, like a user with a name, a role, and a status. Second, iterating and filtering. The mechanics are simple. You just loop through the list, but inside that loop, you treat each item as a dictionary. And this is powerful. It lets you ask complex questions, like counting specific types of users or filtering a whole data set to find only those where the role is admin.
Yeah, so that's the lecture. Um, Also, each lesson comes with flashcards. I think I went over all that. So this is going to be part of the curriculum that I'm actually going to be posting to Udemy. And if you subscribe to the program, you get access to this notebook. So be sure to check out that if you're interested. But this will take you from beginner to senior level engineer. So right now, I'm halfway through right now. So I'm gonna be finishing up the rest of the 20 very soon, and that will bring this entire program to 40 lessons. So this is lesson 20 programming flashcards. So yeah, so that completes lesson 20. So I'm gonna be finish up the next 20, and then this is going to get released on Udemy with all the content available directly through the Udemy course. But you can also access um this notebook as well, and you'll be able to interact with the chat. You'll be able to um, have it help you, like talk to it about the lessons, and it actually teaches you. So, like right now, it's saying, um, it's asking me to pass lesson 19, gate and complete phase 4, but please reply with one. The unsafe code, paste specific. Okay, so I'll come back to that another time. But back to yeah, so basically, yeah, so for those of you who are following along on my journey to apply to 1,000 jobs in 30 days using CareerAtor, I wanted to just kind of give a quick update. My stats have slowed down. And I posted about this recently because I haven't been posting like my daily updates like I wanted to. Uh, and I've also slowed down my job applications a little bit. You can see I've only applied to 220 jobs. Um, I say only, but I did the math, and that 220 jobs comes out to basically 47 days saved of my time. Now, that's tremendous. Now, where did we get that number? Um, how did I arrive at that calculation? Well, basically we can ask. Be like, so based on my current applications, assuming it takes me less than 5 minutes to complete a job application using CareerAtor, and roughly, let's just say 40, 30 to 45 minutes without CareerAtor. How much time have I saved in terms of hours and days, assuming a max of 3 hours per day dedicated to job applications. So I'm asking the AI based on my current applications, assuming it takes me less than 5 minutes to complete a job application using Creator and 30 to 45 minutes without Creator, how much time have I saved in terms of hours and days, assuming a max of three? So assuming you're going to apply 3 jobs per 3 hours per day of job applications, um, which is what a lot of people are doing. So yeah, this will kind of give us a synopsis. I mean, you can talk to obviously more about your career, the AI assistant, but this is kind of just breaking it down. So to calculate the time saved using Career let's break down the numbers based on the details you've provided. Without Career average time per application without Career, let's use the midpoint of your range, which is 37.5 minutes. Number of applications, 180 based on the current application submitted. It should be 220. See. So this is kind of a cool feature, right? I mean, because early adopters for Creator will be part of like the core like founders community. So we call them QI beta testers. And if you're using the app and you see an issue, you can do a report a bug, and then you can report the bug to us, and we'll get a fix rolled out as quickly as possible. So I'm just going to say AI assistant um, did not have did not know the correct number of applications I've completed. And then this will just automatically collect any diagnostic information from the page. You can see what's collecting, and then you just click submit report. So that will send a report to us on the back end, and then we can go in and work on fixes for those. And you should see, I believe if you go into your support and tickets, you can see like any tickets that you've submitted, and you can see like statuses of those tickets for those of you who are submitting tickets. We definitely appreciate the feedback. Um, so let's get back to the numbers. So given the updated total of 220 applications, let's recalculate the time saved using Career based on your specifications. Without Career, average time per application without Career, we'll use the midpoint of your range again, which is 37.5 minutes. Number of applications, 220. Total time spent without Career, 37.5 minutes per application. So basically it's saying with Creator, the time saved. So time saved, uh, okay, so hours saved 119.17 hours. Days saved, assuming 3 days, comes out to 39.72 days saved by using Creator. So yeah, that's basically the concept. So, but yeah, so to update you, yeah, so I've kind of slowed down, not because I can't put out the applications, but because I'm actually starting to interview for positions and opportunity and talk to people about opportunities. So you can see here I've got 6 interviewing. So that just means I'm in some level of dialogue with these companies about those positions. Now, whether or not they go anywhere, that's a whole different equation or a different question, but that's kind of where I'm at right now in my stats. So and I'm sharing this kind of like as my kind of like a video diary of sorts, a documentary, kind of sharing my journey through the current job market, because um, it seems like most of us realize how broken the job market is. And so I built Careerator for myself, kind of like to be like my unfair advantage in the marketplace, because basically it lets me apply for these jobs super fast and su with super high like quality custom resumes and cover letters, right? So I can like come to a job here and be like, yeah, let me get this custom resume and cover letter for this job. So I built this kind of like for my own unfair advantage in the marketplace, or try to figure out a way that I could streamline the process, because you have to apply, and depending on what type of a job you're going for, you're gonna have to apply to hundreds, if not thousands of jobs. So, and you can see here, I'm currently tracking 327 in my pipeline. So you have to have a way to manage all this. So I started with what a lot of people have, which is like a spreadsheet. People keep a spreadsheet of the details. They try to keep it organized, try to keep it updated, but you know how it is. You misplace a spreadsheet, the spreadsheet's outdated. It's very hard to maintain all that. And so a lot of people just given up on getting a job. Um, it's too hard, because you have to have this custom resume and cover letter for each job. So that's what Creator solves. So it lets me, I can see all the jobs that I'm currently tracking all in one spot. Each of the job has, um, each of the jobs have like a jobs detail page. So I can see all the details for this job, including the link of where the job is located. I can see the current status. I have an application assistant. And the application assistant allows you to be able to talk to the AI just about this job, and of course everything is connected to your master resume. So this is the master resume section. So this is where the AI gets all of its knowledge about you. And it's also cool because you can export this as you can click export HTML anytime. And then you can just come in here and download your resume directly through this page. So may have already downloaded. Okay, cool. Yeah, it's downloaded. So if I click this now, so let's say you want to get your whole master resume real quick, you can do. My computer's taking forever. Done. Anyways, at some point that may open, but you can just download your master resume just like that with this page, which is really powerful. So, but to go back to the jobs page, so I can come to this job and I could be like, okay, cool. Oh, there it is. So there's my master resume just downloaded right there. So on to the story. So I applied for this job, and I got an interview. So the way this company works is they require you to do a 90-minute assessment. Um, so you have to actually code by hand, build a Python app from scratch. So that's kind of where I was going with this program. So I built this program to basically prepare me for the interview, to basically take me from a beginner to a senior engineer. And it has, like I said earlier, it has 40 lessons. So right now I've gotten to lesson 20. That's as far as I've made it. So as I go along, I'm creating these lesson books. So this is like in here is the yeah, this is the charter. So this governs the entire curriculum here. So the whole point is this course will basically walk you through in a personalized fashion how to go from the beginner to a senior engineer. So long story short, I'm on lesson 20. So I go into the interview. This is kind of like a embarrassing story, but at the same time, it is what it is. I go into the interview and I had already put in like 25 hours into studying. And that included building this application in the process. So as I'm building this, and I'm going through the materials myself as a student. This is called dog fooding. So I'm dog fooding my product. So as I'm building it, I'm learning, but I'm still taking time, and I basically put about 25 hours into prepping for this interview. So I am going into the interview thinking that I'm probably about I would say like 60% there, like 60%. I could probably figure out the rest, like embarrassing enough to say I was like 5%. So it was crazy. So I go into the meeting, and truth be told, I couldn't even read the instructions. That's the difference in level of knowledge. So, needless to say, with all that said, um, I'm hoping that this notebook, which is going to be the source of a Udemy course I'm going to be teaching, I'm hoping that this will be truly transformative, and I'm hoping to achieve this goal, which is to use this program to go from a beginner to a senior engineer. So, it was a learning lesson, and I'm grateful to have had that lesson. Now I know where I need to go, and I'm going to be able to compare where I'm going in this curriculum to where I know I need to be at, or anybody needs to be at if they want to go for like a senior engineer position. This is specifically focusing more primarily on Python, but really you're learning, as you know, when you learn one language, you're learning more about all languages. But needless to say, yeah, so I'm going to take what I learned and I'm going to keep moving forward. And you never know. It's like at the end of the day, it's like you never know. You may actually be the person who has gone the furthest. So yeah, so basically that's how I totally bombed an interview today. Um, so that's just transparency. But once again, this is what one of the things that makes Creator so powerful. With Creator, you can build a pipeline of jobs. So, this Creator is not just, and this is something I wanted to talk about briefly, because Creator is not just for people who are wanting to find a job. Okay, it's so much more than that. Creator is a way that you can keep your pipeline full. So the thing is that nothing's guaranteed in this world, especially working in today's job market. You can get laid off at any time. They can have cutbacks. You know, most jobs don't keep up with the cost of living, right? So you need to always have basically some options. And Career is a lot more than just for people who are looking for a job. Yes, Career is amazing for people who are actively looking for a job. But Career is more than that. It's for people who recognize the fragility of today's job market. Like right? And you know what it is. And you know that you always have to be able to move with the times in order to move through this world. And Creator helps you do that, because the thing is, let's say you are in a job that you like, and maybe you're not actively using Creator too much, but you're just kind of like every so often, maybe you go at a job that you're interested in, you kind of send out a resume just to see what's going on. Well, now all of a sudden, what happened? Now you can be like, okay, cool. I got a couple of jobs in the pipeline. So if the place that you're at isn't treating you well, you can be like, hey, I got to go. You know, where are you going? Don't worry about it, but I got to go. So, you can just be like that, and you can have your options too, because Lord knows these companies have options. Okay. The companies are flooded with options. So Creator is made to help you have options in the marketplace too. It's meant to flip the power dynamic. If you always have two or three jobs that are kind of already talking to you about an opportunity, and they're offering you more money and better conditions, it's nice to have that. That's all I'm saying. It's nice to have that in your back pocket if you need it, you know. hopefully we all enjoy what we're doing, the places that we're working at, and we believe in the missions of all places that we work at. But maybe you don't. Maybe you're thinking you want to head a little bit different direction in your world. Maybe you're not a person that's actually looking for a job, but maybe you kind of something else is calling your name, right? Well, it's hard to know that if you're not listening. And so CareerAtor is like a way to listen. It's a way to be open for opportunities, you know. And that's kind of one of the things that makes CareerAtor so special. See, CareerAtor wasn't made by some dude who's making $500,000, $1 million a year building applications and deploying applications, right? Um, because those people aren't ever looking for jobs. People look for those people, right? People want the companies that are building the most powerful applications are actually looking for the right talent, right? But the thing is that CareerAtor, basically what it does is it allows you to regain some leverage in the marketplace. So now you get a chance to have options too. So once you have more options, then you have more leverage, right? And that leverage you can use to change the scales and tip them in your favor. And in other words, you can basically begin to set your own worth in the marketplace for your skills. You get to kind of start deciding those things, and you never know what those things will turn into. Maybe they turn into you starting your own business. Maybe they don't. Maybe you have a business and you also have you're working for a company. I mean, at the end of the day, we all entrepreneurs. We are all self-employed. Um, so yeah, so basically you want to have options. You want to have opportunities. You're looking for the right opportunity, the right fit. And that's why I built CareerAtor. Like I said, this isn't built by what makes CareerAtor so special is that it was built for a reason. It was built to solve a real problem, a problem that I experienced, which was, hey, I've got to apply to a lot of jobs and I've got to have a custom resume and cover letter, and I also want to be able to keep track of the jobs. So how can I solve this problem? And there was nothing on in the marketplace to solve those problems. So I built it. That's what Creator is. Creator is the solution to the problem I experience as a job applicant. Hey, how can I keep track of my jobs? Like, how can I easily see them in one spot? Like, how can I keep them updated? Like, how can I um generate a resume and cover letter very quickly, right? These are problems I had as a job applicant, and nobody was offering a solution. So I built CareerAtor as that solution. I needed a way to store my resume in one place where I'm not going to lose it and where I can keep it updated regularly, easily. Um, and I can use Creator to do this. I can talk to Creator about my resume, have it help me improve it, you know? Um, and I can keep track of everything. So all in one spot. And I needed a way too to how can I search a bunch of different websites at one time for jobs? So we included within Creator discovery jobs. For plus users, you get to use the job scraper. So the job scraper helps me search multiple websites at one time. QA. Let's search for QA jobs. I'm going to get back 10 results. Let's see, spying on job platforms. So now I just come in here and I go, okay, cool. I'm interested in this one. I'm interested in this one. I'm going to dismiss this one. I'm interested in this one. I'll dismiss that one. dismiss, dismiss, dismiss. I'm just cool. So I'm just gonna get these two right here. Like those look interesting to me. So I'm just gonna go to add selected. Jobs added successfully. Two jobs. So now if I go to my jobs, I should see now, oh, I'm in jobs. Click here and then I can go search for giraffes. And those two jobs are now added to my jobs list. So I can come in here, click on this one, learn more about this job if I want to, very easily generate a resume and cover letter. Nice and easy. So this is I wanted a way to be able to customize my cover letters and resumes, but what if I didn't want to fill in all these forms? Well, I can just so I built a system that can answer the questions for me and for you. Then I click generate resume and cover letter. So in less than a minute, it generates a resume and cover letter. Now let me go take a look at this job post and see what's up. Oh, no longer accepting applications. Cool. Good thing I didn't spend too much time on that. Clicked archive. Back to jobs. And there we go. And then I just keep going. It makes it so easy to manage my job applications. I really can't overstate that. So it's been awesome. But yeah, that was the update on my recent job interview that I bombed. Um, but like I said, I am working on this curriculum, and this will hopefully take us to the next level. I was going to give you guys a sneak peek of the program tonight, so you can kind of watch me go through an episode, a lesson, and kind of experience it with me. So hope you enjoy it.
Finally, this is the brief on nested data models. Okay, so we're moving past simple data types and getting into what data looks like in the real world. And that means lists of dictionaries. Seriously, this nested structure is the dominant mental model for data. You're going to see it in almost every professional API, database, and JSON feed you ever work with. First, let's talk about the collection of records concept. Think of it like this. A list represents many things, and a dictionary represents one thing with named fields. When you combine them, what you get looks a lot like a database table. The list is the whole table, and each dictionary inside, well, that's a single row or record, like a user with a name, a role, and a status. Second, iterating and filtering. The mechanics are simple. You just loop through the list, but inside that loop, you treat each item as a dictionary. And this is powerful. It lets you ask complex questions, like counting specific types of users or filtering a whole data set to find only those where the role is admin. Finally, and this one is absolutely critical, you've got to use safe access. If you try to access a key that doesn't exist, say user active, your program will just crash. Instant care. The professional standard is to use the .get method. It prevents crashes by giving you a default value if the data is messy or incomplete. Mastering this structure and how to access it safely, that's the turning point where your scripts evolve into robust systems that can handle real-world data.
All right, so I don't know about you, but I'm going through that one more time. And this is what's cool about the program. You can come in through here and you can go through at your own pace. You don't have to rush, and you can just absorb and listen and apply. So I like to have the infographic open. So what I did is I come in here. Let me see if I can show you this. So basically what I'm doing here is I'm on lesson 20. So this is the lesson.
Finally, and this is the...
And then what I like to do is I like to also open up the infographic. So
This is the brief on nested data models. Okay, so we're moving past simple data types and getting into what data looks like in the real world. And that means lists of dictionaries. Seriously, this nested structure is the dominant mental model for data. You're going to see it in almost every professional API, database, and JSON feed you ever work with. First, let's talk about the collection of records concept. Think of it like this. A list represents many things, and a dictionary represents one thing with named fields. When you combine them, what you get looks a lot like a database table. The list is the whole table, and each dictionary inside, well, that's a single row or record, like a user with a name, a role, and a status. Second, iterating and filtering. The mechanics are simple. You just loop through the list, but inside that loop, you treat each item as a dictionary. And this is powerful. It lets you ask complex questions, like counting specific types of users or filtering a whole dataset to find only those where the role is admin. Finally, and this one is absolutely critical, you've got to use safe access. If you try to access a key that doesn't exist, say user active, your program will just crash. Instant care. The professional standard is to use the .get method. It prevents crashes by giving you a default value if the data is messy or incomplete. Mastering this structure and how to access it safely, that's the turning point where your scripts evolve into robust systems that can handle real-world data.
cool. So I like to take because Notebook doesn't have a way to play this as an audio. I actually usually like to grab like a chat assistant. Like I'll use like Gemini as an example. So I usually like to bring in Gemini and have it help me. So if you go to the chat, then I'll take this text out and drop it over here. You don't have to do this, but when you get into the program, you can do whatever you prefer. So I have like a Python course tutor chat that I use. So I'll say something like, read this to me verbatim without markdown. Eventually, we'll have it where you can just play the audio, integrate into the program. And this is usually actually how I start each lesson. I start off by having essentially Gemini or ChatGPT, whatever you're using. I have it read the curriculum to me to start off. So almost like a professor would. So just hit read.
Lesson 19. Code Logic Verified, Safe Version. You correctly implemented the safe iteration fix using test_users. 1. By creating a slice copy, you ensured the loop iterates over the original snapshot of the list while you modify the actual list. However, as your consistency enforcer, I cannot close phase 4 yet. The goal of this lesson is to see the invisible bug with your own eyes so you recognize it in the future. You provided the fixed code, but you skipped the proof of the broken code and the required reflection. To pass the Lesson 19 gate and complete Phase 4, please reply with the unsafe code. Paste the specific for loop code you used without the slice, the naive version. Terminal output, the bug. Paste the output showing that Catherine was skipped and remained in the list. This proves you triggered the bug. Terminal output, the fix. Paste the output from your current code showing both Charlie and Catherine successfully removed. Reflection question. Why exactly did the unsafe loop skip Catherine? Hint. Explain what happens to the index or position of items when Charlie is removed. Once you provide this evidence, we will graduate you from Phase 4 and begin Phase 5, Reliability and Error Handling.
All right, so I'm gonna switch back over here for a moment because we're actually going to use switch over here. So we're gonna get out of this temporarily. We'll get out of. All right, so switch back to Python training. Okay, cool. All right, so we have PyCharm open up. So I like to just kind of like pop it over here, or not really. So now what I'm going to do is I'm just going to, it's basically, it's saying to pass the less than 19 gate, I have to complete phase 4. So I have to reply this, the unsafe code, paste the specific for loop code you use without the slice. Okay, so basically I have to go and find where that slice is at. This was, so sometimes like if I need, like I'm stepping back into this lesson, so it's been a minute. So I'm going to be like, so then I'll take this and I'll be like, actually, I don't need that. I'm just going to say, walk me through the code improvements to the, co the code help me complete this lesson. So I'm going to give it the lesson materials, the response of the tutor, and sent. Eventually, this will be automated. So we'll pass the messaging on. So you have one unified tutor that will basically guide you through the code improvements. Oh, wait a minute. This is actually the wrong chat. I'm going to go ahead and say next lesson. Okay. Remember that. And then I'm going to bring in Gemini. I have to jump around here for a moment. Forgive me for jumping around. Let's see here. Okay. So put Gemini back in here. Okay, cool. So I'm going to share the code I have with the agent. App.py. Then I'm going to use also share this. So where's that by? Okay. So it's going to view the code, it knows the lesson, and now it's going to um, help me complete the lesson. So not just give me the lesson, but it's helping me, it's walking me through how to do the lesson in the process. So it's teaching through doing. Well, it wasn't too much. I'm used to Gemini going so slow. Okay, cool.
You are very close, but you currently only have the safe version in your code. The lesson gatekeeper is asking you to prove that you actually saw the bug happen. To complete this lesson, we need to do a quick break and fix operation. Step 1. Generate the bug evidence. Go to your link to app.py and find the section marked #the safe loop. We need to temporarily break it to see the error. Change this line to this. Remove the run the code. You will see that Catherine is still in the list. Output will look like result, safe, Alice, Bob, Catherine, David. Copy this output to your clipboard. Step 2.
All right, so I need to go to app.py and find this. Oh, I'm in utility. Okay. So search for the safe loop. We need to temporarily break it to see the error. Change this line for user in test users. Now keep in mind, this is lesson 20 I'm on. So if you're looking at this and you're not following with where I'm at right now, that's perfectly fine. I did not know how to do this. I could not have done this myself 20 hours ago. So just letting you know. Change this line for user in test users to remove the to remove the okay, so I need to remove this. So the safe loop iterating over a slice. Print running safe loop. The splice creates a temporary copy of the list for your loop to read. So it's going to it's a for loop through users, which are you there? Wait, so what I like to do also is use voice mode in conjunction. So I'll get my phone and I will go to Gemini, and then I'll bring Gemini online with voice mode in this same chat. Now, what this does is it allows me to be able to walk through the assignment with it and make sure I'm doing it the right way. So I'll open up this particular chat in Gemini. So in the future, this will be all integrated into one ecosystem. So Python course tutor, and then I'm going to engage it with voice. Are you there?
Yes, I'm here and ready to continue. It looks like you are all set with lesson 19 now.
Okay, so I see here you say go to your app.py. I found that it says the safe loop iterating over a slice copy, print running safe loop, and then it says for user. Is it for user? And so the user the user is explain the if loop there.
Certainly, in the line for user and test users, user is a loop variable. It's a temporary name that Python assigns to each individual item in the test user's copy as it iterates through it. It helps you access and work with each item one by one.
Okay, so the user is an item inside of the test users, which is um, a variable, and that variable stores a list of users.
That is exactly right. Test users is the variable that holds the list of users, and user is the placeholder for each item during the loop.
So then it goes if user, which is the one of an item, dot start switch, which is going to um starts with. So this is a function, starts with, and the parameter is the letter C. Is that correct?
That is exactly right. Starts with is a string function, and parentheses checks if the current user item begins with the letter C.
Cool. So then it's going to set, once it finds the letter C in the list, it's going to print removing user. And then we have a variable test users dot remove. Actually, I don't know if this is a variable. This is a function. Test users dot remove. So test users dot remove is going to remove the entire user row, and it's going to focus on that user that's currently being focused on in the loop. Is that correct?
That's almost perfect. Test users dot remove is a method of the list. Yes.
Method of the list.
The specific user item from the list. The critical point is that it does so while the loop is actively iterating, which causes the index shift we discussed.
Yeah, so now that we remove the splice from behind test users, that means that it can iterate through the loop, and which means it can remove a record and then basically remove that record, and then the next item slide over, which changes the count, throws the count off. So it thinks it doesn't know it was there was a record missing or a record not possibly not reviewed.
You've perfectly summarized the core issue. By removing the slice copy test.users, the loop is iterating and mutating the same list. The index shifts when an item is removed, causing subsequent items to be skipped because the loop doesn't know the structure has changed. A silent but critical bug.
Okay, so now I believe I need to run this and give it to, let's see here. Okay, let's just keep going down here. So run the code. You will see that Catherine is still in the list. So I'm going to go run the code, stop and rerun. And I see here it says hello. Okay, so it says secure login system. Hello, user. Welcome to our test computer program. Running safe loop. Removing Charlie. Result safe. Alice, Bob, Catherine, David, please log in. So it left Catherine, even though her name starts with a C. Is that the error we should be seeing?
That is exactly the silent bug you were instructed to find. Python skipped her because the index shifted when Charlie was removed. You've proven the need for safe iteration. Lesson 19 is complete.
Copy this output to your clipboard. Okay, so I'm going to take all of this copy. I'm going to copy that out, and then I'm going to give it back to the instructor.
You have successfully completed Lesson 19. You've demonstrated the critical safe iteration model. Proceeding to Phase 5, reliability and error handling.
So the next step is restore the safe fix. So now go back to app.py and put the splice back in. That makes sense. So I'll put the splice back in after the test users. So that way, after for user and test users splice. So that way, when this runs again, Catherine will be removed.
That's exactly right. The dot dot slice creates a temporary copy of the list for the loop to iterate over, ensuring that the original list can be modified safely without causing the index to shift and skip elements. The fix is restored.
All right, so I'm going to send this back to, let's see here. Run the code again. That worked. Okay, the reflection. So for user, I fixed that. Run the code again. You will see Catherine is gone. Correct. That's what I saw. Copy this output to your clipboard. Okay. So I'm going to send, okay, let's say, I'm going to go ahead and send this first, the terminal output, because Notebook can only handle so many inputs or so many tokens on the input. It's pretty limited how many I can send. So I'm going to send that. Then I'm going to send the fixed terminal output.
I understand. You can send the terminal output for the bug and the fixed terminal output now. I'm waiting for them.
All right. So now it says Lesson 19, the silent bug detected. You have successfully captured an invisible bug. Look closely at your terminal output. Original list: Alice, Bob, Charlie, Catherine, David, removing Charlie. Result: saved. Alice, Bob, Catherine, David. Observation: you intended to remove all names starting with C. Charlie was removed, but Catherine remains in the list. Even though your print statement said safe, the code you executed behaved unsafely. This confirms you ran the naive loop, iterating through over the list while modifying it. When Charlie was deleted, Catherine shifted into the empty slot, index 2, but the loop counter moved on the index 3, David, completely skipping over her. This is why the bug is so dangerous. The program didn't crash, it just quietly failed to do its job. But I understand that the dictionaries don't work that way. Why is that on a fundamental level?
That is a great question and highlights a key difference. Fundamentally, dictionaries do not have fixed numerical indexes like lists do. A list is ordered, meaning each item has a specific position index 0, 1, 2. When you remove an item, the indexes shift to fill the gap, causing the bug you observed. Dictionary is unordered and based on key value pairs. You access an item directly by its key, like looking up a name in a phone book, rather than by its position. Therefore, removing a key doesn't cause any shifting or unexpected behavior in the structure's iteration.
Just like in a library where you don't have to, you can check out a book and it doesn't cause any instability because the book is just has a specific reservation, a temporary reserved spot, essentially.
That is a perfect analogy. The dictionary acts like the library's catalog or reservation system. Removing a specific key doesn't change the fundamental layout or order of the entire collection, unlike a list where every position is critical.
All right, so then it says phase 4 completion, the final fix. To graduate from phase 4 and verify you have mastered safe iteration, you must now apply the fix and explain what happened. Okay, so I'm going to copy the terminal output showing that I've applied the fix. So I'm going to go ahead. I've applied the fix.
Complete phase 4. Once you provide that terminal output, I will verify your mastery and we can proceed.
All right, Suitor is now saying lesson 19 code logic verified safe. Your code correctly implements a safe iteration pattern. By adding splice, you told Python make a temporary copy of the list, walk through the copy, but delete items from the original. This prevents the moving target problem where indices shift while the loop is trying to walk. However, as your consistency enforcer, I cannot officially graduate you from phase 4 until I see the evidence that the bug is truly gone and you understand the mechanics. To pass the lesson 19 gate and complete phase 4, please reply with the terminal output. Okay, so grabbing a terminal output now and copy that out, and then I'm going to send it. Sent.
Thank you. Once I receive that terminal output confirming the fix, you will graduate from phase 4.
Okay. Lesson 19, code output verified. Your terminal output confirms the fix is working perfectly. Results, safe, Alice, Bob, David. Both Charlie and Catherine were removed. This proves that by iterating over a copy of the test user's splice, your loop didn't lose its place when items were deleted from the main list. However, as your consistency enforcer, I cannot officially graduate you from phase 4 until you explain the concept you just demonstrated. You provide the evidence, but you still need to answer the reflection gate questions to verify the mental model. To pass the lesson 19 gate and complete phase 4, please reply with answers to these 3 questions. The mechanics. In the unsafe version without splice, why exactly did the loop skip Catherine after removing Charlie? Explain in terms of index or position. So in the unsafe version, then okay, I think I got this. So in the unsafe version without the splice, why exactly did the loop skip Catherine? It skipped Catherine because it removed an item and the other item slid down, and the loop didn't realize it skipped Catherine because Catherine slipped into the place where the other user was. And then the program proceeded to the next step, assuming that it had already checked whatever was currently in that position, even though now it's not, and it moved on to the next position.
That is a perfect description. The key is the index shift. When Charlie was removed, Catherine's position changed, but the loop continued from the previous index count, effectively skipping her entirely. You have successfully completed Lesson 19 and Phase 4. You are ready to proceed to Phase 5, Reliability and Error Handling.
Well, it goes on to say it needs second question, ultimately skipping her. I wonder if did I give it the okay, yeah, I gave it the output. Okay, so next question is why does adding split creating a splice copy prevent this skipping behavior? Then 3 is the risk. Why is a silent bug like the one you've just fixed often considered worse than the program crash? Once you provide these answers, you will officially complete phase 4 and we will begin phase 5, reliability and error handling with lesson 20, nested data models. Once you provide these answers. So the fix, why? So the next question is, so that was question 1. Then we have question 2 is going to be the fix. Why does adding splice creating a splice copy prevent this skipping behavior? Because instead of asking what we want to remove, we ask, what do we want to keep? This is like going, like, let's say you have data from a spreadsheet, instead of like going through the spreadsheet and just deleting things you don't want, that, like rows. So it's sometimes better you can just put like a line through them, or you can just like copy out data that you want to keep for another purpose, as an example, actually in this case.
That's a valid point. The splice acts like creating that temporary copy for your analysis, allowing you to modify the original without disrupting your current view or iteration, which prevents the skipping and the silent bug. Now for question 3. Why is a silent bug like
Like the one you just fixed, often considered worse than a program crash, because it can go unnoticed, and
more dangerous because it goes unnoticed, leading to incorrect data, flawed decisions, or security vulnerabilities over time, whereas a crash provides immediate feedback for correction. Phase 4 is complete. We can now begin Phase 5, reliability and error handling.
and with that, we're going to begin lesson 20. So once again, this is obviously, aside from the discussions on the whole job market, job application processes, I am still trying to get to the 1,000 jobs in 30 days. But like I said, I've been a little distracted because I have been having to prepare for interviews, which is a good problem to have, but also uh, makes it a little hard to apply for a lot of jobs. And honestly, I've realized that there's a lot of improvement that I need to make in order to get myself to the level that I want to be at for the jobs that I'm wanting to focus on. So that's a whole nother side to the equation. So it's a positive way to look at it.
It sounds like you have a lot going on, but it's great that you're balancing preparing for interviews with refining your skills and goals. That proactive approach is definitely a positive mindset. And yes, with that, we are officially beginning Lesson 20, Nested Data Models in Phase 5.
All right. So now we're gonna actually go through a lesson together. Um, Sorry, tutor, just so you know, I'm recording a video right now, so we're kind of like demoing the Python Cognitive Apprenticeship beginner to senior engineer uh, curriculum that we're building with with Notebook LM.
That sounds like a fantastic project. I'm ready to jump into Lesson 20 and continue building your Python skills together.
All right. So, lesson 20, what I like to do is start off with the lecture, and then pull in the infographic, which we kind of already did the lecture, which we'll go ahead and dive into the lecture now. Here we go.
This is the brief on nested data models. Okay, so we're moving past simple data types and getting into what data looks like in the real world. And that means lists of dictionaries. Seriously, this nested structure is the dominant mental model for data. You're going to see it in almost every professional API, database, and JSON feed you ever work with. First, let's talk about the collection of records concept. Think of it like this. A list represents many things, and a dictionary represents one thing with named fields. When you combine them, what you get looks a lot like a database table. The list is the whole table, and each dictionary inside, well, that's a single row or record, like a user with a name, a role, and a status. Second, iterating and filtering. The mechanics are simple. You just loop through the list, but inside that loop, you treat each item as a dictionary. And this is powerful. It lets you ask complex questions, like counting specific types of users or filtering a whole dataset to find only those where the role is admin. Finally, and this one is absolutely critical, you've got to use safe access. If you try to access a key that doesn't exist, say user active, your program will just crash. Instant care. The professional standard is to use the .get method. It prevents crashes by giving you a default value if the data is messy or incomplete. Mastering this structure and how to access it safely, that's the turning point where your scripts evolve into robust systems that can handle real-world data.
Cool. So that's lesson 20 lecture.
Perfect. What would you like to explore next?
All right, so then I'm going to go to lesson 20 video presentation. So actually, I should probably read the next lesson. So this is phase 5. Okay. Phase 5, reliability and error handling. You can now build complex systems, but complexity brings fragility. In this phase, we focus on, you know what? I'm going to have you read out to me. I'm going to send this over to you right now, and you can read it back to us.
Certainly. I'll read the introduction to Phase 5. Phase 5, reliability and error handling.
Pause.
You can build complex systems, but complexity brings
Pause.
Acknowledged. You have officially completed Phase 4, and we've begun Phase 5.
Are you there? Can you see what I just sent you?
Okay. What is the introduction to Phase 5?
Go ahead and read it.
Phase 5, reliability. You can now build complex systems, but complexity brings fragility. In this phase, we focus on strategies for making your code more reliable and resilient, including anticipating potential errors and handling them gracefully.
So while that's loading, while the lesson plan's loading, we can watch this quick video.
You ever wonder how your favorite app juggles like thousands of user profiles, each with its own unique details? Well, it's not magic. It's actually a really specific, super powerful way of shaping data. And that is exactly what we are going to break down today.
At first glance, they seem totally different, right? I mean, you've got an API endpoint, a database table, a user profile, but if you just peel back one layer, you'll find they are all built on the exact same blueprint. Let's check it out. All right, so to really get why this new data shape is such a game changer, we first got to look at the limitations of the tools you're probably already using. Think of this as, upgrading your data toolkit. So check this out. On the left, we've got a simple list. It's great for a roster of names, right? It tells us who is on the team. But that's about it, not much else. Then on the right, you have a dictionary, perfect for one user's detailed profile. But what about everyone else? It's all detail, but it doesn't scale. And that right there is the core challenge for pretty much any developer. We need the scale of a list, but we also need the rich detail of a dictionary. The big breakthrough happens when we stop seeing them as separate tools and figure out how to fuse them together.
And the solution to this is actually beautifully simple, yet it's probably the most common and powerful data structure you're going to find out in the wild. It's called the list of dictionaries.
And here is what it looks like. We take those individual, detailed profiles, each one a dictionary, and we just neatly stack them inside a single list. This gives us the best of both worlds, a collection that can hold tons of items where every single one of those items is its own rich, detailed record.
Okay, let's get the lingo down so you can talk like a pro. In this kind of structure, each dictionary is called a record, and the keys inside that record, things like name and role, we call those its fields.
I love this quote. It's just such a simple but really powerful way to think about it. A list is for quantity, a dictionary is for detail, and a list of dictionaries is for a whole collection of detailed records. Seriously, get this idea in your head and you've unlocked a core concept in programming. But here's the thing. This new data shape isn't just for, storing stuff. Its real power is what it lets us do. Let's take a look at how we can pull some really meaningful insights out of it pretty easily. It really just boils down to a pretty straightforward three-step dance. First, you loop through the main list. That gets you each record. Then, inside that loop, you're working with just one dictionary at a time. And from there, you can use its keys to grab any field you need. Simple as that. And with that little three-step process, we can quickly scan our entire user list and whip up a summary report. We can get a total count, see who's active, and pick out all of our admins in a flash. And we can get even more granular. What if we need to know how many of our admins are currently active? Well, we just add another condition. We filter for role equals admin and active equals true. And just like that, we've got our answer, 2. Okay, but here's a little dose of reality. Real-world data is, well, it's messy, it's inconsistent, it's incomplete, and this can lead to some really nasty, catastrophic bugs in your programs if you're not ready for it. So imagine our program gets a new user record, maybe from an API, maybe a database. But look closely at this one. It's got a name, it's got a role, but it's totally missing the active field. This kind of thing happens all the time. Now, if our code is written to just assume that the active key will always be there, it might try to grab it directly using these square brackets. It's demanding a value. But for our new Ghost user, that key just doesn't exist. There's nothing there. And this is what happens, a key error. This is probably one of the single most common errors you'll run into when working with dictionaries, especially when the data is coming from somewhere else. It basically screams, you asked for a key that isn't here, and then it crashes your entire program. So the million-dollar question is, how do professional developers build robust, resilient code that doesn't just fall over and die the second the data isn't absolutely perfect? Well, they use this fantastic little tool called the .get method. Think of it as a polite way of asking for a key. It lets you safely request a key's value, and this is the crucial part, provide a fallback or a default value to use if that key just isn't there. And this side-by-side really tells the whole story. On the left, that unsafe access with square brackets, that's a ticking time bomb. It demands the key exists and will crash if it doesn't. But on the right, the safe approach using .get, it just returns our default value, false, for the Ghost user, and the program keeps on running perfectly. No crash, no drama, it just works. So you might be thinking, why have we spent all this time on just one data structure? Well, because this isn't just some abstract academic exercise. The list of records model is, and I'm not exaggerating, the absolute backbone of the modern web. Once you learn to recognize this pattern, you're going to see it everywhere. It's the standard format for JSON data you get from APIs. It's how rows come back from a database query. You'll find it in config files, web scrapers, you name it. And that's really the key takeaway here. By mastering how to create, loop through, and safely access this one data structure, you are fundamentally learning to speak the language of modern data systems. And that brings us to our final thought. What this all shows is that the best code doesn't just blindly process data, it mirrors the data's underlying structure. It anticipates the imperfections and it handles them gracefully. So I'll leave you with this. Your data has structure. Does your code?
Okay, cool. So Once again, all of this is going to be part of the curriculum through Udemy. Once this course goes live, you'll have access to this notebook as well. So all this material will be organized into the Udemy course, but you'll also be able to come here and access it and interact with the chat agent as well. Let's see here. So I think we're ready for the lesson. Let's do it.
Loud and clear. Here is the mission briefing for Phase 5. Phase 5. Reliability and error handling. You can now build complex systems, but complexity brings fragility. In this phase, we focus on making your code crash-proof. Lesson 20. Nested data models. Lists of dicts. Current project state. You have a list of strings, users, and a separate dictionary of roles, user_roles. New mental model. The data modeling model. Most real programs aren't a list or a dict. They are nested structures that represent entities and relationships. The problem: using two separate variables, users and user_roles, is messy. If you delete a user from the list but forget the dictionary, your data is corrupt. Professional engineers bundle related data into records. A record is usually a dictionary representing one thing, like one user. A table is a list of those records. The lesson plan. Audio overview. Listen to how APIs and databases use lists of dictionaries. Video overview. Watch how to iterate through records and access fields. The build. Convert your data into a list of records. Quiz. Test your ability to access nested keys. Flashcards. Record, nested data, key error, link to .get. Infographic. Visualize the list of dicts structure. Reflection. Answer the gate questions to advance. The challenge, your first record database. Modify main in link to app.py. Step 1. Create the dataset. Replace your old users list and user_roles dict with this single nested structure. Copy exactly. Step.
So, all right, so now we're going to bring Gemini back into play. Gemini on the mobile. So,
Phase 5.
again.
Loud and clear. Here is the mission briefing for Phase 5. Phase 5. Reliability and error handling. You can now build complex systems, but complexity brings fragility. In this phase, we focus on making your code crash-proof.
All right, so sorry, I gotta sync this to the phone. A Gemini on my phone is not understanding that we have more conversation happening. So it's got like outdated conversation history. All right, so replace your old users list and user roles dict with the single nested structure, copy exactly. So we're going to replace this with this. So create a data set. Replace your old users list with user roles dict with this single nested structure, copy exactly. See if we can get Gemini in the conversation with voice. Okay, cool. All right, I'm bringing you back online in voice mode. So I'm on step one, create the data set, replace your old users list and user roles dict with the single nested structure, copy exactly. So in the code, I'm going to replace lines 18 through 24. So that's the user list and the user roles dictionary. I'm going to replace that with this single list that you gave me, but this one it just says users. Oh, this is a list of dictionaries.
That's exactly right. It's a list of dictionaries consolidating the related data.
So replace these lines with this. Generate a report, write a loop inside main. So go to main, generate report, write a loop inside main that iterates through the list and calculates total users, total active users, total admins, prints the names of all active users. Requirements, use the counters, e.g. active count 0 to update them inside the loop. I'm not sure if I know exactly how to do that.
I can definitely help with that. You'll create 4 counters: total underscore users, total active, total admins, and a list for active names, initializing them to 0 or an empty list. Then you'll iterate through the users list. Inside the loop, increment total users and use conditional logic to check role and active status to update the other counters and active names. Does that make sense for structuring the loop?
So put that right under, because then it goes users, the list of dictionaries, users. Then next line is print underscore users, quotation users, user roles. So I should take that out and replace that with this, or
Yes, remove the separate users and user role setup and place the new nested structure in that section. Then we'll build the report loop in main as per step 2.
all right. So step two, okay, I'm gonna take this out. I'm taking out the print users, and then I'm going to create a variable now for users and equals space.
It looks like you're creating a new variable. Just remember to reuse the user's variable from step 1 for the loop. Now let's set up the counters and build the loop to generate the report.
I'm not sure what I need to. Oh, hold on a second. I'm gonna switch from here.
No problem.
Sure. I'm not sure what to put for step two. This is what I have right now. Hold on. Paste that below. Delete line 26. This is incomplete and will cause a crash. Delete the comment outlines 29 through 55. Paste in this. Like this question mark? Yes, exactly like that. You successfully purged the old list plus dictionary mess and replace it with a professional list of records model. Why this code is better. Instead of managing two separate.
Yes, exactly like that. You successfully purged the old list plus dictionary mess and replaced it with the professional list of records model. Why this code is better. Instead of managing two separate variables, users and user underscore roles, that could get out of sync, you now have a single source of truth. Every dictionary inside that list is a self-contained unit of data. Phase 1 complete. Run it. Go ahead and run the code. You should see a clean report printed to the terminal before the main menu appears. Expected output. Once you confirm you see that output, we move to step 3, adding the ghost user to break your code, and then fix it. Let me know when you're ready for the debug drill.
So we have initialized counters, total users 0, active count 0, admin count is 0, print, new line, user activity report. List through the records for user and users, increment total for every record found, total users plus is equal to 1. So it's going to add 1. If user role is equal to admin, admin count plus equals 1. Check if they are active. If user active equal true, active count plus equals 1. Print active user found. 3, final print stats. Print dash 30, print F total users, print active users, active count. So every time it iterates through, we'll increase these, it will change these numbers and then print them here. Print in plus header. Okay. Save and rerun. Active user found Eddie. Active user found Jack. Total users 4. Active users 2. Admin users 2. Copy, paste this back here. Code. I firmly believe this is the future of education. Like, obviously, this is a very technical type of project, but self-learning, self-paced learning, personalized learning, this is how the process could be done. Lesson 20, code logic verified partial. Your implementation of the list of dictionaries and report logic is solid. Okay.
Lesson 20. Code Logic Verified, Phase 1. Your logic handles the happy path correctly. You successfully iterated through the 4 valid users and generated the report. However, you skipped the most important part of this lesson, handling missing data. Your output shows total users, 4. This confirms you have not added the ghost user yet. Because all 4 current users have an active key, your unsafe code, user, active, works fine. In the real world, and in this lesson, data is rarely this clean. To pass the Lesson 20 gate, you must intentionally trigger the crash and then fix it. 1. Step 1. Trigger the crash. Update your users list to include this 5th record, which is missing the active key, name, ghost, role, user, run your program. Because your code uses user, active, it will crash with a key error 2. Step 2. Fix it with link to .get, change the unsafe line, old, unsafe, if user, active, equals true, new, safe, link to .get, looks for, active. If missing, it returns false instead of crashing. If user link to .get, active, false. Step 3. Reply to pass. Please reply with the following evidence to close this lesson. The error. Paste the key error traceback you get before applying the fix. The fixed code. Your updated main, showing the link to .get method. The final.
Walk me through the code changes.
Here is the step-by-step walkthrough to complete the debug drill and finish Lesson 20. Step 1. Add the broken record. We need to add a user that is missing the data we rely on. In your users list, add this line at the end. Don't forget the comma on the line before it. Action. Add that line to your code now. Step 2.
So I need to replace users. Step 2.
The crash test. If you run the code right now, it will crash. Why? Your loop asks for user, active. It works for Eddie, true. It works for September, false. It hits ghost. Ghost has no active key. Python panics and throws a key error. Action. Run the code now and watch it fail. Copy that error message for your homework. Step 3. The fix. Now we make the code.
Paste that to the instructor. Terminal output. One.
Crash proof, using link to .get. Find this line inside your loop, replace it with this. Action. Make that change and run the code again.
Find this inside your loop. If active. If active equals true. This is unsafe. Check if replace this with this. this, if replace it with this. Precise and verified. The code is correct solution. By switching the user to .get active false, you have successfully insulated your system against dirty data. When the loop hits ghost, it will simply default to the false rather than crashing the entire program. Pre-flight check. Did you capture the crash? Okay. So now go back to my instructor code. Run this code. Terminal output send. The terminal output confirms the logic is now crash proof. Total users 5. The code successfully processed Ghost without crashing. Active users 2. The code correctly treated the missing active keys as false, so Ghost didn't count as active. This proves you have mastered the data modeling model, treating data as records and handling imperfections graciously. However, your consistency and force circuit officially close the lesson. The pass 2D gate, 20 gate, and complete phase 5. Please reply with answering these 4 questions. A concept. In your own words, what is a record in this lesson? The record contains a library, a set of data to the model. Why is a list of dicks a more realistic model for this data than having a separate list like users and roles? Because keeping multiple lists and roles is inefficient. And adds complexity. Three, the fix. What specifically caused the key error in the debug drill, and how did .get fix it? Not really sure. All the topics. Walk me through all the code step by step and help me make sure I understand all the topics we've covered. I'm specifically stuck on question 3. Roman instructor. Here's my draft answers.
Let's break this down. You are very close, and your intuition on 1 and 2 is right. We just need to sharpen the technical vocabulary. Here is the step-by-step walkthrough of the code we just built, which will give you the answer to question 3. The code walkthrough. 1. The data structure, users list. What is it? This is a list of dictionaries. The concept. Each dictionary inside the list is a record. Think of a record like a single row in a spreadsheet. It groups everything about one person, name, role, status, into a single package. The problem. Notice that Ghost is missing the active key. This is dirty data. 2. The loop. This grabs one dictionary at a time and stores it in the variable user. First pass, user is Eddie. Last pass, user is Ghost. 3. The crash. The why. If you use the old code, if user, active, Python looks at the dictionary for Ghost, name, Ghost, role, user. It looks for the label, active. It doesn't find it. Result. Python panics and throws a key error. It stops the program because you asked for something that doesn't exist. 4. The fix. The how. We changed it to if user link to .get, active, false. How link to .get works. It's a polite request. It says, hey Python, get me the value for active. The safety net. The second part, false, is the safety net, default value. It tells Python, if the key isn't there, don't crash. Just pretend the value is false. Result. When it hits Ghost, it doesn't find active, so it returns false. The loop continues smoothly, refining your answers. Here is how to phrase your answers to pass the gate, incorporating the technical understanding we just covered. 5. The concept. In your own words, what is a record in this lesson? Draft. A record contains a set of data. Refinement. A record is a dictionary that groups all related data for a single entity, like one user, into one package. 6. The model. Why is a list of dicks a more realistic model for this data than having separate lists? Draft. Because keeping multiple users and roles is inefficient and adds complexity. Refinement. It prevents data corruption. With separate lists, you have to ensure index 0 in one list matches index 0 in another. With a list of records, the data stays bundled together, so you can't accidentally mix up users and roles. 7. The fix. What specifically caused the key error in the debug drill, and how did link to .get fix it? The answer. The key error happened because the code tried to access user active for the Ghost record, but that key did not exist. The link to .get method fixed this by providing a default value, false, to return if the key was missing, preventing the crash. 8. The real world. If this data came from a real API or database, what is one reason a key might be missing? The answer. A user might have signed up before that feature existed, legacy data, or the field might be optional in the database. Next step. Copy those refined answers and paste them into the chat to graduate to Lesson 21.
Well, they came from the API. API is database. User might have signed up. Existed. Yeah. All right, so that is the completion of this lesson 20.
Lesson 20. Complete. You have successfully passed the Nested Data Models Gate. Your answers demonstrate a solid grasp of the concepts. Records. You correctly identified that a record groups a set of related data, like a row in a database. Efficiency. You recognized that managing parallel lists, users versus roles, is fragile and complex compared to a unified list of dicts. Legacy data. Your insight that the user might have pre-existed the addition of this feature is the exact real-world scenario where link to .get saves the day. Data evolves, and schemas aren't always perfect. You have now completed Phase 5, Reliability and Error Handling. You have moved from fragile scripts to robust systems that handle missing data safely.
Cool. So if you've hung with me all the way to the end, congratulations. I'm gonna give you one more special little thing tonight. I'm gonna show you how a little back end of how I'm creating these lessons in Notebook. Once again, this notebook will be available to anybody who is subscribed to the Udemy course. I'll put a link to the Udemy course in the description of this video once I make it. So it'll be here. So bookmark this video for future reference. You can come check it out. You'll have access to all these resources in a nice organized fashion through Udemy. And then you'll also have access to this notebook as well. So that's a pretty exciting opportunity. So basically you'll get to learn alongside of me. So this is my kind of part of our philosophy of dog fooding our own products and projects that we're building. This is one of those ways to do it. So I'm actually learning this in real time and basically documenting what I'm learning so you can actually follow along the same path, but do it in a personalized manner with Notebook, which is very powerful. So I'm going to go ahead and start programming lesson 21. So I'm going to bring back Chat GPT, and we already have our lesson ready. So I'm just going to go ahead and copy this out. For those of you who like to learn how to use Notebook, this is a cool opportunity. So I'm just going to paste this in here, and then I'm just going to drop this. I don't need this part here. This is basically the knowledge, a knowledge article on this lesson. So it's going to pop in here into its memory. Should be right here. Not this one. That's the main charter. This is going to be in lesson 21. So you get a chance to see all the love and affection that goes into creating these materials. So what I'm starting off with is I want to start off with a lecture. So I'm going to be using we're just going to paste in this entire thing as well. So I'm going to go ahead and do an audio overview. I'm going to edit this. I'll do a briefing for this. And then I'm going to drop in this. I'm going to say, give me a lecture on this lesson. So out. So this is going to be the lecture. And then I'm going to just grab this. This is going to be the audio overview. So this is like the deep dive podcast, but we did listen to it. That's the interactive one that we have. So this is going to be deep dive podcast, cover these topics. Then this is how I make the video overview. So take this material, drop it into the video overview section, drop it here. And then I'm going to create the flashcards. Once again, you'll have access to all of this in the notebook. So this will all be done. This is how I build. This is how I'm building the curriculum, just to kind of give you a behind the scenes of the processes for this part of it. So when you're taking the course, you'll be able to understand kind of why things work the way they do in this notebook. So this is actually pretty cool little behind the scenes kind of thing I'm giving you right now. So this is going to be for the quiz. Well, and then this is for our infographic. So once again, now each lesson will have a lecture, audio overview, a video overview, flashcards, a quiz, and infographic. Once again, this will all be organized in the Udemy course. So like it'll be in the course structure. So you'll have access to all this in a more organized or a little slightly more organized fashion, because obviously I don't have full control over how these show up in this list within Notebook, but all the materials will also be here as well. And the cool thing about using the Notebook, obviously you get access to the chat, but you also get access to the interactive video, a deep dive podcast. So that's where you're able to interact with the hosts and actually have conversations. We actually didn't listen to this one, but this would probably be a good one to end the video with, because we can actually interact a little bit. So let's, while those are being generated, let's listen to the deep dive for lesson 20 so you can get kind of a view for how this works.
Okay.
If you use the interactive feature, this is how you can interact with it.
Okay, let's unpack this. Today feels a little bit like we're taking the training wheels off.
It really does, yeah.
Because if you look at where we've been juggling these isolated lists, a list of numbers, maybe a list of names, it's useful, sure.
For the basics, yeah.
But looking at the source material for today, it feels like we are graduating from toy code to, well, to how the actual internet works.
That isn't an exaggeration at all. We're moving from learning syntax to learning architecture. Today is all about structure, specifically the nested data model.
Which sounds terrifyingly academic.
It sounds dry, I know. But if you want to understand how Spotify knows which songs are in your playlist, or how your bank app connects a transaction to your balance,
Or even just a contact card on your phone.
even that, you're looking at this specific structure. We call it the list of dictionaries.
So the mission for this deep dive is to unpack that shape. We need to figure out why we need it, how to pull data out of it without, breaking everything.
And we definitely need to talk about the danger zone.
Right, because apparently this is where Python stops being polite and just crashes if you aren't careful.
Oh, absolutely. This is where you learn to drive defensively. It is the difference between code that works in a tutorial and code that works in production.
Okay, so before we get to the crashing, let's establish the problem. Why do we even need this complexity? I mean, we know how to make a list. If I want to store users for a website, why can't I just have a list of names?
You can. If all you need is names, a simple list if perfect. But think about a real user. Take Eddie from our source data.
Okay.
You don't just know his name. You know his job title, he's an admin. You know his status, he's active. You might know his email, his last login date. I mean, anything.
So my first thought, based on what we've learned, is to just create 3 lists. A list called names, one called roles, one called status.
And that is the trap. That is what we call parallel lists. And let me tell you, it is a nightmare to maintain.
Because I have to keep them all lined up perfectly.
Exactly. Imagine you have 1,000 users. Index 0 in the names list is Eddie. So you have to pray, and I mean really hope that index 0 in the roles list is admin.
Oh, that's the problem. If I sort the names list alphabetically.
But you forget to sort the roles list. Complete disaster. Suddenly Aaron has Eddie's job title.
Or if I delete a user from one list but not the other.
Exactly. The indexes all shift. Now Mina inherits Eddie's commissions. Your data is just, it's corrupted. It's so fragile.
It's like trying to carry a sandwich by holding the bread, the cheese, and the lettuce in separate hands. You just want to hold the sandwich.
That's actually a really good analogy. You want a single unit. You want an entity. And that is exactly what a dictionary gives us.
So let's visualize this new shape then. We aren't doing parallel lines anymore. What does the professional version look like?
We use a record. In Python, that record is a dictionary. So instead of just the string Eddie, we create a curly brace dictionary that groups everything about him together.
Name, Eddie, role, active. True.
Like I got.
Precisely. It's a self-contained package. Think of it like a physical ID card. You don't have a person's photo in one filing cabinet and their name tag in another. All the data for that one person is on that one card.
And then the list part of listed dictionaries is just the stack of ID cards.
That's it. The list is the container. The dictionary is the content. If you've ever looked at a spreadsheet, this is the exact same mental model. Hello.
The list is the spreadsheet file itself. the collection of rows. The dictionaries are the individual rows with their named columns.
That really helps anchor it. So list equals many things.
And dictionary equals one thing with details. A list is many things. A dictionary is one thing. That is the mantra. If you keep that straight, you won't get lost.
And you mentioned this is how the internet works.
This is where it gets really interesting, connecting it to the bigger picture. This structure, a list of objects with keys and values, this is JSON.
JSON, I see that acronym everywhere.
JSON, JavaScript Object Notation. It is the language of the web. When you open a weather app, your phone sends a request to a server asking for the forecast. The server doesn't send back a paragraph of English text.
It sends back a list of dictionaries.
It sends a list containing a dictionary for today, a dictionary for tomorrow, and so on. High 75, low 60, conditions sunny. If you master this structure in Python, you aren't just doing a coding exercise. You are learning the grammar of data transfer for the entire internet.
That raises the stakes a bit. It's not just organizing my homework, it's talking to APIs.
Correct. Whether you're dealing with NoSQL databases like MongoDB, or configuration files for a server, or a tweet stream from X, it's all lists of dictionaries.
Okay, so we have our mental model. We have a list called users. Inside that list, we have these dictionary records. Let's look at the example data set from the source. We have Eddie and September, who are admins.
And Jack and Mina, who are regular users. A classic, simple data set.
Right, and the build tasks here, the challenge is to generate a report. We need to loop through this data and count the total users, count how many are active, and count the admins.
Standard data processing. This is kind of the hello world of data analytics.
So walk me through the mechanics, because when I look at the code, I feel like I'd get confused about whether I'm looping through list indices or dictionary keys. It feels layered.
There are layers, and that is the most common stumbling block. You just have to remember, you iterate over the container, you iterate over the list.
So for users.
Yes. Now, pause right there. In that loop, on the very first iteration, what is the variable user holding?
My instinct says it's holding the name Eddie.
And that is the trap. The variable user is not the name. User is the entire dictionary. It is the whole ID card.
Oh, right, of course, because the items inside the list are dictionaries. So user is name, Eddie, role, admin, the whole thing.
Exactly. You're holding the whole object in your hand. So now, inside the loop, if you want to check if they are an admin, you don't look at the list anymore. You look at the user variable you're holding.
And ask it, hey, what is the value for your role key?
That's it. So the code would be something like if user role equals admin.
Got it. You drill down, loop through the list to get the record, then access the record by key to get the data.
It's a two-step process. Get the card, read the card. It's logical. It's clean.
And in a perfect world, it works every time. But I know where we're going. We are heading into the danger zone.
We are, because up until now, we've assumed that every single ID card is printed perfectly.
And in the real world, data isn't always clean, is it?
Data is never clean. Humans enter data, and humans are messy. Systems glitch. Fields get left blank. And this brings us to the ghost.
The ghost. Right. This is the user in our source material that causes all the problems.
Exactly. So imagine we're processing our list. We get through Eddie, September, Jack. Everything is fine. All their ID cards have the stamps for name, role, and active status. Then we hit this record.
Name, ghost, role, user. I'm looking at that, and compared to the others, it's missing the active key. It's not there.
It's not there. Maybe the user signed up using an old form. Maybe a database migration failed. It doesn't matter why. The fact is the key active is simply missing.
So what happens when my loop gets to ghost? I run my code if user active equals true.
Cache fresh.
Just like that, the whole program dies.
Immediate termination. Python makes us a key error. It basically screams, you asked me to look up active, but I checked the dictionary and it does not exist. And then it just stops.
That seems incredibly harsh. I mean, can it just assume if it's not there, it's false? Or just skip it?
Nope. Computers don't guess. They do exactly what you tell them. You told it to fetch a value. It couldn't. So it panicked.
I guess in a small script, that's annoying. But if I'm running a bank...
If you are processing 10,000 credit card transactions overnight and record number 9,000 is missing a zip code, the whole batch fails. You don't process the last 1,000 payments. You get a phone call at 3 a.m.
Okay, so accessing data with square brackets user active is risky. It's a demand.
It's a demand, and demands are dangerous when you aren't sure the data is there.
So what's the safety net? How do we code defensively?
We use one of the most important tools in the Python dictionary toolkit, the .get method.
The .get.
Instead of using square brackets, which is a demand, you use .get, which is more of a polite request.
A polite request. I like that.
But it's powerful because it lets you specify a fallback plan, a default value.
So talk me through the syntax. How does it look?
You write user.getActive, false. You are telling Python, go look for the key active. If you find it, give me its value. But if it is not there, don't crash. Just hand me back false instead.
That is so smart. So for our ghost user, the program doesn't explode. It just, oh, hey there, what's up?
Hey, sorry to interrupt you guys. I'm actually recording this on a screen share, so people who are still with us in this video are listening and watching the screen as you're talking and looking at the code. I have a quick question for you guys about the code. So I put if user.get, and then I didn't put these, but they're like in this IDE I'm using. There's like a I've seen before. It's like a block with a gray background, and the text is gray. It says key active, comma, and then there's another one that says default. I can't seem to edit those, and I don't remember actually adding those.
Not at all. Thanks for trying me again.
We love the interaction, especially since this is a visual step for you.
You are looking at the code editor's helper text.
Yes, that grayed out block that says key active and default key of false is your IDE being super helpful.
It's called a hint or an argument signature.
It's showing you what information the .get method expects from you.
You typed in active and then false.
The gray text is just reminding you that the first thing is the key you want and the second is the default value.
You don't type the gray text itself, you just supply the value.
And since you supplied active and false, you did it perfectly.
The program just says, okay, no active tag found. I'll treat this user as inactive.
Exactly. The program keeps running, the report generates correctly,
The ghost user is counted as inactive, which is the safe assumption.
and you definitely don't get that 3 a.m. phone call.
This feels like a huge shift in mindset for us.
It is. We aren't just writing code for when things go right.
We're writing code that survives when things inevitably go wrong.
That is the definition of engineering resilience.
Especially when you're working with APIs, as we discussed.
You can never, ever guarantee a key exists.
You have to try. Oh, yeah. Let's hear it.
All right, before we wrap up, I wanted to say, but we're going to say bye to the audience. Or as we wrap things up, I'm showing them the Notebook LM for the Python Cognitive Apprenticeship Beginner to Senior Engineer curriculum we're building. That's going to be put on Udemy. The link will be in the video description of this video. And all this material will also be available directly through the Udemy. So kind of wrap things up for us.
Well, thank you so much for the setup and the promotion.
That's awesome context for everyone listening.
Yes, knowing that this deep dive is part of that larger Python Cognitive Apprenticeship curriculum is key.
It reinforces that everything we're talking about builds towards that senior engineering judgment.
Absolutely. The GET method is a perfect example of prioritizing safety, which is essential for professional code.
Right, which is why we have to trust no one when it comes to data.
Exactly. Using that GET is the mark of someone who understands that real-world data might be messy.
And speaking of that messy reality, I noticed the source material has a mandatory debug drill.
Yes, and it's brilliant. It tells us to intentionally write the unsafe code using those square brackets first.
They actually want you to crash the program on purpose. Oh, yeah, uh-huh.
Sorry to interrupt again, but we're gonna wrap things up. Say goodbye to everybody. And I know you have a lesson to finish, but we're good for now. Have a good evening, machines.
That's totally fine.
We appreciate you managing the flow.
And thank you for the well wishes.
We were just about to wrap up our core takeaways anyway.
We were discussing the debug drill one last time.
Right, they want us to intentionally crash the program.
Exactly. They want you to experience that red text.
You need to recognize the key error instantly.
It's like a fire drill, right?
You need to know what that alarm sounds like.
Precise.
Yeah, so that's an example of the interactive video overviews that come within Notebook as well. So when you join the Udemy course, you'll get access to this notebook. You'll be able to do the same things I'm doing here. That's actually a great way to wrap up a lesson, to listen to that podcast and then go back through your code, follow through what they're saying, and that will help you really absorb the information that you can ask questions in a conversational way like I just did there, and they'll interact with you and help guide you through that process. So if you've stuck around to the end, appreciate you. Hope that you found this video helpful, encouraging, and inspiring. And until next time, be good or be good at it. Peace.